Hit the low notes better when you go. Here we go. Number one. Enough of that. Idle chit chat. Number one, Zachary.
226.
2/65. Thank you for offering. Number two, Autumn.
$2.20.
$28. We are well on our way to having a world record-setting time here. 2 is $28. 3, Fish.
C.
I have D. 3 for 3. It's going to be a great test. Number 4. Do we have to do number 4? What's it say? If an image on a computer screen is increased by what? Increased by what percent? I will accept either 225 or 125%. How about that? Can we get either one of those two? Yes. So far we have 2. We may punt on that one, by the way. Number 5. Sarah Grace. CE is 13 centimeters. EF? 6 centimeters. And FB?
50.
Correct. CE is 13. EF is 6. FB 15. 6. Maya.
156 centimeters.
156 centimeters squared. 7. John.
142.
142. 8. Emily. $24. Thank you. Is that what you were going to say? I just thought this was taking a long time. 9. Emily, I'll give you another shot. Emily doesn't want another shot. Emma?
1,000 pi inches cubed.
Did it say to leave in terms of pi?
No.
Because I have the same answer, except I have 3,140, which would be 1,000 pi. Emily, any of these? Number 10?
820.
I have 628 inches squared. 628 inches squared. Number 11, did it say to graph via XY intercepts? Is that what it is? Crosses the x-axis at 3 and the y-axis at 2. Oh, hey, I got it right here, so I'll just do it. That means this. Did I say x-axis at 3, y-axis at 2? So it looks a tad like that. Just a tad. Number 12, a couple people had questions, so I will just tell you the answer is this. X equals C minus B all over A. C minus B all over A. 13, X should be greater than -1. X should be greater than -1, which means that -1 is a colored in circle. The line shoots off to the right. Off to the right. Number 14, when all the smoke clears, you get 2 quarts per minute. 2 quarts per minute. 15 is 2.4. 2.4. 16 is 3 over 2. 3 halves. Ladies and gentlemen, 3 halves. 17 is 2 over 3xy to the third. 2 over 3xy to the third. 18 is 2x squared plus x. And last but not least, number 19 is -6. And certainly last, more last, and certainly not more least, 20 should be 6 times the square root of 2. 6 times the square root of 2. Gianna, let's talk about answers first. Now we get to that. That will be the first one I do when I get to the how do you do parts. Does anybody have a question over what an answer is? Sarah Grace Taylor. 15 is 2.4. 2.4. Layton. 10 is 628 inches squared. Great. What does 16 ask you? Does it say solve for x, or is it a ratio problem? I don't have 16. Forget it, I'll look here myself, Grace. Number 16 said, I'm guessing either way is fine. I don't know what the problem is just yet. 16. Yeah, you could have it as 1.5 if you like. That'll change one a little. 3 deep breaths, ladies and gentlemen. All right. Well, just Gianna said, which one Gianna was that again? 12. Good question. Multiple people asked me this, ladies and gentlemen, and I told both of them the same thing. People asked me. not sure who they were, but I know two people asked me this. And here's the deal, children. Anytime you are solving something for a letter, you're not going to get a specific number because this thing just can't, because there's multiple variables. They said to solve for this x, okay? Always, always, always think about what you would do if it was just a normal equation that had numbers in it. In other words, if this was 3x plus, well, let's just go 2, plus 2 equals 11. And you were asked to solve that still for the letter x. What would be the first thing you would get rid of? What do you do first? You do what? Somebody help me, Grace? Subtract the 2, right? You want to get it over there. Well, that's the same thing here, except it's not a 2, it's the letter B. So you subtract the letter B. The problem with that is you can't, they're not like terms, so you can't really subtract it from the C. You have to just write it as C minus B. That's all you can do. You're left with the AX over there. So once I did this, I'd end up with 9 over there. That works out because they're right terms. Then the last thing you do to get x by itself here, 3x equals 9, this is ax, you would do what? John? Divide by, to get x by itself here, you divide by the 3, correct? Well, it's not a 3, it's an a, but you do the same process. You divide by a, because a divided by a goes away. And what you do to one side, you have to do to the other. And there's all you can do for your answer. They're not numbers that combine or anything. It is simply x equals c minus b over a. That is it. That's all you can do. That was it. Zachary.
Instead of when people ask,
What's that?
instead of when people ask what problem, I would just do them all. And we do them all. Yeah. Huh?
Well, however, I understand that, Zach, but this also helps me that usually people ask for the hardest ones first, so I get kind of some sort of a range for that. You want me to start at the beginning and go to the end? Is that what you're saying?
Let's try. I'm confused.
Like, so we start at number 1, like energy number 1, and then we do
What is probably more productive is if we would spend 20 minutes talking about what we should do first. Would that be better? So I agree with you, Zach. All right, let's just go to the beginning and do it. Although I might lose some of the audience at the beginning, but let's see. Let's see, we're kind of big here. A deck of 26 alphabet cards, calculating 1 card for every letter, including A, E, I, O, U. 1 card is drawn. Here's the key, ladies and gentlemen. This is pivotal. It is not replaced. You don't put it back in after you draw it. Then the second card is drawn. What's the probability both cards will be vowels? Probability of picking a vowel and a vowel without putting the card back. Anytime you have 2 probabilities back to back, you multiply their probabilities together. So it would be the probability of the first vowel, picking the first vowel, and then the probability of picking the second vowel and multiplying those together. Well, how many vowels were there? 5, right? Out of how many total letters? 26. That's the first time. The second time, though, you already picked 1 vowel out, so there's not 5 left in there. There are now only 4 vowels in there. And there's not 26 letters because you took 1 out. There's only 25. So here are your 2 probabilities. You just need to multiply them together. Please make your life easier by cross-canceling before you do that because you don't want to have to reduce all that. 5 goes into 5 once and 25 5 times. Cut this in half, you get 2. Cut this in half, you get 13. And when all the smoke clears, you end up with 2 times 1 on top, 13 times 5 on the bottom. Your probability of picking 2 vowels in a row. But you're good, because this saves me a lot of time. Alex figured she'd save $12 by buying an item at 30% discount. How much did she pay for the item? Ladies and gentlemen, this really is the best way to do this is with a percent box. Is it a discount or a markup or a markdown problem? It is. It's a discount. So you're taking off a percentage minus the discount. Your original price minus the discount equals final price. We're talking about percents here, and then you have the actual numbers there. What is my 30%? Is that the original percent, the discount, or the final percent?
Discount.
Looks like it's discount. And original is going to be 100. So your final, pretty easy, you're paying 70%. Is $12 the original price, how much she saved, or what the final price is?
What she say?
She saved, that's her discount. So there is, ladies and gentlemen, the numbers you know. They want how much did she pay for the item. That's the final price, not the original price. How much will she pay? Now watch how nicely this works out. There's not a whole lot left to do. You can just leave this like this and know that this is this fraction, 30 over 70 equals 12 over what number? I'll rewrite it. 30 over 70 equals 12 over what number? Please reduce because it'll make your life easy. Divide both by 10, you're left with this. 3 times 4, 7 times 4. Your answer is $28. How much was it originally? $40. Didn't ask you that. Don't matter. Not gonna care. You need to stop me if something didn't make sense. So I don't.
$28, correct?
What?
$28.
$28. Otherwise, I would fly by this like it's nobody's business. Number 3, which of the following is not a character of the graph displaying direct variation? If I were taking notes, this is what I would write down. Number 1, direct variation has to go through the origin. And number 2, it has to be a straight line. Which also means it must have a common, what do we call that? Factor, but what's it called? There's a special thing we use for it. Constant factor? Constant factor, whatever. So, you think about this. The graph is a line or aligned points. Is not. Well, that obviously, because I said it was, it has to be a straight line. That was one of our things. So this is not the answer, because it said this, they want something that is not a characteristic of. We talked about it. It has to go through the origin. So that is, the slope of the graph is positive. The graph lies in the second and fourth quadrants. Here's the deal. If it lies in the second and the fourth quadrants, that means it goes like this, and the slope aligned with the origin. The slope of the line is positive. Wait, the question is, does it have to be or doesn't it have to be? It's something that does have to be, right? Wait, it doesn't.
Which of the following is not?
Not a characteristic. And the answer was D, right?
Yeah.
Right, because it doesn't go in the second and fourth quadrant. But why couldn't it be? Because you could have a straight line that goes through the origin here. Are you not allowed to have
I
negative
think
slope?
it means like it has to be in there every time, like it can't be alone.
Oh, that is true. I guess it could happen, but it doesn't have to. But this, yeah, I might skip that one on the prompt test. How about that? I don't like the way, sometimes I just don't like their wording. Let's just go with that. The beauty of when you're the teacher, you can skip that. I'll look at that one and see if there's something I'm missing on there. Number 4, we are going to skip that one for right now. If I have time, I'll go over it. If not, we'll skip that one too. Just because I don't want to spend the kind of time it's going to take. It's better to do a lot of them and get a bunch more, have time for all of them, than to do one and miss all the rest. So let's wait on that one. Figure ABC is a rectangle. Refer to this figure to answer questions 5 and 6. What is the length of CE, EF, and FB? CE, EF. Was this one that was labeled wrong, or was that something else? Alright, forget that question. And EF. And FB. Facebook. Now, how do you know what these things are? How am I going to figure out what this one is? Somebody? Think of this right angle, this triangle. Yeah, Pythagorean theorem. Is a 5, 12 thing up there a triple?
Yeah.
Yes.
Yes, which means it is
13.
13. Stop. Get that? Same thing here. What's that?
Are we allowed to use that Pythagorean?
Yeah, absolutely. First of all, it's up on the wall, so you ask if I'm not going to let you look up on the wall. But you can use whatever there. This one here, you look, there's not a 9, 12, but, ladies and gentlemen, but this, you have to understand there's a common factor that I can shrink this down to C, because that only gives me the base ones. If you divide these all by 3, 9 divided by 3, you get a 3 here. Divide this by 3, you get a 4 here. Is there a 3, 4 triangle? Yes, it is a 3, 4, 5. But 5 is not my answer because that's the ratio line. You have to multiply it then again by 3 to get back to the big one. This has to be 15. And then how do I find EF up there? Well, it's a sum of its parts. You know all the way across is the same 20 down here. You have 5 and you have 9, so what number added to 5 and 9 gives you 20? It would have to be 6. 5 plus 9 is 14, 14 plus 6 is 20. So those are the questions to answer, the answers to questions number 5. Number 6 asks you what? What is the area of trapezoid BCEF, which you're going to write down the formula for a trapezoid. The area of a trap is 1/2 base 1 plus base 2 times height. Hopefully you didn't have to have me tell you to do that, and you did that. The question is, what are my bases? How do I know what my bases are and why? Bases have to be the two
Top and bottom.
parallel. Now it's not top and bottom, it's the two parallel lines. Again, remembering you are only talking about this trapezoid here. We're not doing the whole thing, just the trapezoid. Base 1 and base 2 are this line and this line because they are parallel. So you make it 20 and 6. And the height is always perpendicular to the base, so you're looking for the right angle. Here's your right angle. The height formed by those two lines is 12. So 20 plus 6 is 26. Still have that half. You can half this any way you want. You want to do half of 26, half of 12. Let's do half of 12. Half of 12 is 6. 26 times 6 is 156 centimeters squared. Got that? Could have multiplied 26 times 12 and then cut that in half. Could have cut half 26 in half and got 13 and multiplied that by 12. You'll still get 156. We are just cruising for an absolute solution here. Formula for this sequence is a sub n equals n squared minus 2. What is the 12th term of the sequence? Ladies and gentlemen, you do not. This is immaterial. They don't even need to tell you this. You just need to know that when you talk about this sequence formula, the letter n is the number of the term. And they told you the number of the term right here. You just take that and put that in for the letter n. And you will get your answer. This part is all immaterial. Now you can put the letter n here, but it doesn't matter. You just read this as the 12th term. The value of the 12th term is 12, because that's what n is, squared minus 2. 12 squared, 144. And you subtract 2 from 144, you get 142. Everybody good with that? Or you could just keep doing whatever that is. What do you do there? Up 5. What's that? Up 7. No, it'd probably go, this is up 3, up 5, up 7. You go up 9, up 11, but you'll start to get kind of torn up there. How much money is 66 2/3 of $36? And again, anytime you see that word "of" in math, you should be taking this. And the issue with this is this, ladies and gentlemen. I think the book said recognizing rational numbers. You don't want to change this to a decimal because there is no decimal to change it to. It's repeating, it's irresponsible, it's irrational, or whatever it is. I don't know, it's something. Okay, so you want to make sure that you have your little fraction, whatever percent change. 66 and 2/3 changes to what is a fraction?
2/3.
Simply 2/3. And you multiply 2/3 times $36. Put that over 1. And 2 times 12 is 24 smackers. You can stop me if you want me to go slower over that. Yes, Emma?
I did it with decimals and it worked.
Not possible. Not if you did it exactly with decimals. Because at some point you'd have to round.
I rounded.
Yeah, so you round it. Did it say to round?
No.
I'm just saying, you can't do it exactly. I mean, you can do it if you're assuming that you're going to round. That would be fine, but you can't always assume such things in math. I mean, you could do it if you wanted to do 0.66666. How many decimals did you round? Did you put out there when you did your decimal? Just 2?
Yeah.
And you came up with probably, doesn't matter. Number 9. Are we already on number 9? This is going much faster, Zach. That was such a great suggestion. Make sure you have the volume of a cylinder written down. What is the volume of a cylinder? But pi r squared, which is the area of the circle, times the height. That's your volume of a cylinder. So volume equals 3.14. Now, does it say to leave in terms of pi? No. Times, what's the radius? Radius is half of the diameter, so it's times 10, times 10, times the height, which is 10. That is where Emma, I believe, said 1,000 pi, or 1,000 times 3. They probably figured you could do this kind of mentally, so it wasn't that bad. Move the decimal 3 places over, 3,140 inches cubed. You're going to ask me the surface area of the cylinder, by the way? Is that the next thing? Or the top how lateral surface area? What's it? Lateral surface area. Lateral surface area, boys and girls and children of all ages, is everything except the 2 circles. So the lateral surface area of a cylinder, LSA of a cylinder, is going to be the circumference of the circle, pi times diameter, that gives you the top, and you just multiply that simply by the height. So I would write this, I don't know if you have this in your notes or not, but that would be the formula that gets you that. Pi times diameter times height. LSA equals 3.14 times the diameter, which is 10, I'm sorry, diameter was 20, right? Times the height, which was 10. So that is 3.14 times 200. 0.00826, 2 decimal places, 628 inches squared. Can stop you if I'm flying by way too fast. Make sure you have those formulas. Formulas, ladies and gentlemen, are your friends. This one here sketched a graph of that equation. What form is this in? This is in standard form. It's not slope-intercept. And you solve it by finding the x-intercept, and you find the y-intercept, and you just connect those dots. To find the x-intercept, you cross out or put 0 in for y, it goes away. 2 times what number is 6? That is 3. So here at 1, 2, 3, where it crosses there. Find the y-intercept, you put 0 in for x. 3 times what number is 6? That is 2. That crosses the y-axis here. You don't have to deal with slope if it's in the standard form. You just put the intercepts and you graph. And you graph, and you graph, and you graph. 12, ladies and gentlemen.
We did.
Is that a completo? 13, solve and graph on a number line. Anybody know what I'm going to tell you to watch out for when you see inequalities? This is a problem. That negative x means at the end you're going to flip-flop it's to its opposite and that sign's going to change. But before you do that, let's solve for it. So we subtract 3 to get rid of the 3. Subtract 3, you get 1. I now have a negative x is less than 1. Can't have negative x's, so we changed it to positive, opposite, 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 opposite. And then the graph of that is here at -1. We'll open circle. I thought I said closed circle, didn't I?
You did
Yeah.
say yes.
I am going to say the book has. You look at number 13. Prove to me that that book does not have a closed circle there. I'm not just looking at stuff. This is not my fault.
Why
It
does
does
it
have
have
closer.
I will take the fault when it's my fault, but it should be open. It should be open and going this way. I'm the first person to admit when I'm wrong, but I wasn't. I read what the book had in the book. It's wrong. Convert 30 gallons per hour to quarts per minute. That means you're going to need 2 unimultipliers because one is going to change gallons to quarts and the other one's going to change hours to minutes. What does that look like? Well, I'm going to get a different shade of something. Let's go green. I hate green, but we'll do it. This is what it should look like. 30 gallons per minute. You should have started off with that fraction. 30 gallons per, oh, sorry. Right, somebody tell me. It's not per minute, it's per hour. Who wants to change what to what first? Brian Diedrich, which one should I change first? Gallons or hours?
Hours.
Hours. So hours is on bottom, so hours will have to go on top up here. You're changing it into minutes, so minutes have to go on the bottom, and there are 60 minutes in an hour. There's my first conversion. So now my hours are gone, and I am now going to change my gallons into quarts on the bottom because it's on top there. How many quarts in a gallon? 4. So now my gallons are gone. What am I left with? I'm left with 30 on top times a 4 on top over a 60 on the bottom. And it's quarts per minute. Can I cross cancel? Sure I can. Divide this by 10. Oh, well, let's do them both by 30. Divide by 30, that's 1. Divide by 30, that's 2. 4 divided by 2 is 2. Looks like it's 2 quarts per minute. Did I get that right? I don't remember reading that answer. 2 QPM. You gotta stop me if I'm going way too fast. Wait, where'd all this blank stuff come from? If I were leaving notes to myself on this one, do not forget that when you do equations, the first thing you look at is, can you simplify anything on either side? And in this case, you can. You can put these two together. If you have 1x and you subtract 0.5x from it, it's almost easier if you talk in terms of money. If you have $1 and subtract 50 cents from it, what are you left with? 0.5. 1 minus a half is half. X. That equals 1.2. And then from all my, see, that's why you write notes to yourself on tomorrow. Please combine those things. And then of all, what? You're still
When
questioning
you
something.
combine the 1 and x.
1x minus half of an x is still half of an x.
Oh.
If you want to put a fraction, it won't change anything in your answer. You can change it to fractions. That'd be fine. And the other thing, watch out for, please, ladies and gentlemen, make sure you know which one you're dividing by here. I see people put these all backwards. They try to divide 1.2 into 5, and that's what it is. You are dividing by 0.5. You are dividing by 0.5, which means 0.5 goes on the outside into 1.2, which is 5 into 12. 5 goes into 12 twice. That's 10. 5 goes into 20 4 times. 2.4. And the book will, because the problem is in decimal form, they'll give the answer in decimal form. You know, if you had 2 and what? 2/5, I guess that would be acceptable as well. They gave it decimals. And I will tell you when it gets to 16, the first thing that pops in my head is flip and multiply at the end because I see a fraction in front of the letter. But before I do that, how do I isolate this? I have to get rid of the 1/3. Sir Grace, how am I going to get rid of that 1/3? How do I get rid of that? What'd she say?
She said add.
Exactly, you do the opposite. It's minus 1/3, so you add a third. If I add a third to 2/3, I get 3/3, and that's a good thing, because that's a pretty simple number. So now I have 2/3, x equals that. This is the same thing as 1. How do I get rid of this fraction? Flip and multiply. Flip and multiply. Guess what 1 times 3/2 is?
3/2.
Is it okay if you reduce her?
Yeah, if you change it to 1.5, that's fine. I would not like that one. Number 17. There's so many different ways to go about 17. First thing I'd probably do is do the numbers. 4/6 reduces to a 2 on top and a 3 on bottom. Then the next thing I'd probably do is change my negative exponent to positive by moving this y to the bottom. A y and a y squared gives you y to the third, y cubed. And now I'm left with an x squared on top and an x to the fourth on the bottom. Oh, wait, I'm sorry. You have an x squared and an x on top, which means you put those together, you have an x cubed on top and an x to the fourth on bottom. Well, if you have 4 x's on the bottom and 3 x's on top, what's going to happen? These 3 will cross off with those 3, leaving with just 1 x left on the bottom. And that, ladies and gents, is your answer. You can do no more than that. This is too bad. Crying shame. How much time? Oh, we might have time to do that last problem here. How about combining like terms or collecting like terms? Please understand this. You cannot put x squared with x's. Your answer won't have any x to the fourths in it because there's no x to the fourths to start off with. Right? There's no x cubes there. You're going to get x squareds and x's in your answer because that's all you have to start with. I have 3 x squareds. I am taking 1 x squared away. That means one of these goes away. What am I left with? 2 x squares. There's no x to the fourths there. They don't change exponents. Here I have 2 x's, x plus x, and I'm taking 1 of them away. I'm left with just an x. It doesn't become an x squared simply by magic. Zach, this was the best idea you've ever had, just to go number after number. I don't have to try to muddle around with everything. This one here, if you think in terms of order of operations, you should do parentheses first, which means this parentheses doesn't do anything, it's just a -2. But this one you do have to do. Okay, well this parentheses is actually simplified, but the next thing you do is exponents. So before you think about this, you have to do 2 -2's times themselves. A -2 times a -2 is a +4. But there's still this one hanging out there, so a negative and a positive makes it a -4. 3 negatives there will give you that negative there. And then this is not multiplication, this is addition. -2 and a -4. -2 and a -4 gives you 6 negatives, -6. And then lo and behold, problem number 20. As I run out of steam here. Problem number 20, you can do multiple ways. You could multiply the square root of 6 times the square root of 3 and get 2 times the square root of 18, and then break that down into what times what gives you 18. Well, square root of 2 times the square root of 9, square root of 9 is the square root of 3 times the square root of 3. That's the whole thing factorized. So you end up with a 2, a square root of 2, and 2 square roots of 3. Well, if you get identical square roots, cross off and give you just that number gets re-multiplied with the other number like it. 2 times 3 is 6. This one does not have anything to cross off with, so it ends up with the square root of 2. Questions over anything I've done so far? And then I'm going to go back to that other problem back there. I may make this one actually credit tomorrow. Not this one, but the one I'm going to do. Where'd it go? This one. Please understand the problem with this one usually is in the wording of the problem. The question you are asked is its area increases by what percent? Okay, it increases by what percent, not what is its final percentage. Okay, so if you're thinking of your, let's start at the end and work our way back to it. Okay, this is an increase in percent. We have the original plus the increase equals the final percent. Okay? So, the original is going to be 100, the rest we'll have to figure out. And this is what their areas are. So again, we talked about this. You get to make up whatever you want, and I will make up mine 10 times 10. That's my,
Or
so,
7 red chickens.
what?
Or 7 red chickens.
Did you do 7? 7. Now, here's what you have to understand. If you increase the dimensions by 50%, okay, you increase it. What is 50% of 10? Half of 10 is, that's how much you're increasing the dimensions. Okay, I'm increasing both by 5, so my new dimensions are 15 by 15. That is an increase of 50%. And now if we pump up our areas, the first one was a 10 by 10, so its area was 100. The final area was 15 times 15, which is 225. Take my word for it. Notice what those were. That was my original area, and that was my final area. Okay. I increased my percent by 50%. These are my percentages. Okay, and my final percent, oh wait, I'm sorry. My final percent was 225%. My increase was 125. I'm sorry. Actually, I needed to go backwards, sorry. Let me do it the right way here. Hold on, back. Alright, here's my percentages. This, I know my 100, I know my 225, right? How much did it go up? The actual area went up 125, correct? 100 plus 125 is 225. Since this and this are the same, they're all going to be the same no matter what. All the numbers are the same. And they're asking you for this box right here. Those of you that said 225, you were answering this question. You didn't answer how much the area went up. You answered what the final area was. And they asked you for the increase, which is this part. Again, I will probably make that extra cut.
Wouldn't that be nice of me?
Yes. Thank you.
Wouldn't that be exceptionally? Anybody want to review any of those again? Zachary.
20.
What?
20.
20 again?
Yeah. I was writing on this stuff.
The 2? What part on number 20, which was this, Zach? Let's do it one more time. 2 times the square root of 3 times the square root of 6. Now, Zach, you don't have to, by the way, you don't have to multiply these together because you're just going to factor them anyways. So you could factor 3, but 3 doesn't factor, so you still have that. You can factor 6. What times would give you 6? Square root of 2 times the square root of 3. That's the whole thing prime factorized. Okay? Are you with me?
Because 3 is already.
3 was already factored all the way.
That's 2.
6 is 2 times 3. Now you look for pairs of square roots. This square root of 3 is, and this square root of 3 are the same. That's the square root of 9, which is 3. That's a normal 3, not a square root anymore. This square root of 2 doesn't have anything to cross off with, so it has to stay the square root of 2. And then the 3 times the 2 that you started with ends up giving you a 6 square root of 2.